Hey there, welcome back to the channel. Today we're going to continue working on our circuits for our automotive controller. Specifically, we're going to look at monitoring the charging system, so the voltage output from the alternator. Let's get to it. Since we're going to be running off of battery voltage or system voltage, we might as well at least monitor it. It'll allow us to see what the state of the charging system is. Typically we run around 14 volts if everything's charging properly, about 12 volts if the vehicle is off. This circuit here is going to allow us to check that. So we have our battery voltage in here, comes through a couple of resistors, and then out another one, and then we're going to monitor here. This is really just a voltage divider, just like we did for the temperature sensor. The main difference here is that instead of having a variable resistance for the sensor, we have constant resistance on both sides of the divider, and we're varying the input voltage. Really, we want something that measures, let's say around top of about 18 volts. Typically, your car shouldn't be running more than about 14 and a half unless it's overcharging. So this circuit here gives us a pretty good range for that. One thing you'll notice in here is I have this Zener diode, and the reason for this is that charging systems on cars can be a real pain. The charging system on your car usually runs around 14 volts-ish, but the nature of the mechanical charging system, the alternator, and all of the other peripherals on it are you can get these really large spikes called transients that come through the line occasionally, 60 volts, even higher than that. And you want to be able to prevent those from getting over here to your microcontroller. Because if we take in, something along 60 volts, it's just going to fry our microcontroller. In fact, anything above about 5. So we want to make sure this can't get above 5. Really, we can't measure above 3.3, so somewhere in the 3.3 to 4 range is where we like to top out. This Zener diode effectively is like a valve. When the voltage up here gets too high, it'll effectively open up and then let power go straight through to ground. That's why we have these two resistors on this side of the divider instead of just one here. If we only had one here and not one on this side, when this exceeds the voltage for this Zener, we basically are making a short circuit. We would like to avoid short circuits. So this at least provides some resistance to flow through that diode when we have a transient that goes above 18 volts is what I have for this one. Let's go take a look at this in simulation. It'll make a little bit more sense. Here I'm simulating that circuit that we just saw using iCircuit. Got a link for it down in the description. Here is the battery voltage. We're coming through that 100 ohm resistor, then through the 2.2, then here's the 470 and back. This is where our input will be into the microcontroller. So right now, if we have a battery voltage down here at 14 volts, we're going to get 2.38 volts on our input for our microcontroller, which is great. That's exactly what we want. If we're undercharging somewhere down here, around 11 volts, you can see up here, we're going to get just over 2 volts, which is great. Now if we start overcharging, 16, you can see, notice up here, you can see the current is now starting to flow through that Zener diode. Most of it is going around through our voltage divider, but some of it is bypassing, and that's at 19 volts. Our input, we're reading 3.16, but let's say we got a big spike and it jumps up to 60 volts. You can see pretty much all of the current is going to flow through that Zener, and we're peaking out at 3.22 volts at the microcontroller. So that's exactly what we want. Even if we run this way up, you can see A 100-volt spike should only give us 3.2 volts. This should allow us to monitor typical alternator output and typically system voltage, and if we have a transient or something goes really high, it's going to protect our microcontroller from smoking. Let's go put this on a breadboard and see how it looks when we actually run electricity through it. It's not near as easy to see here as it is on a screen, but we've got our voltage comes in here, goes through this 100 ohm, and then travels down this. We've got our Zener that goes across back to ground here. And we have our 2.2K here. Behind it is this 470 that goes back to ground. And then this is the midpoint of that divider. So this is where we're going to sense. This is what the microcontroller would be looking at here. And then the ground for it. You can see I have the meter connected here. So on the voltage divider and ground. The output is here. Let's see if we can get this all in together. So if we power up our circuit, 14 volts, which is typical for our automotive system at normal. It's giving us 2.4 volts to our microcontroller. Now let's adjust this. What happens when we're undercharging or not charging at all? Say we've got it on but not running. Maybe around 12 volts. Oh. Alright, what happens when we're not charging? When maybe the vehicle's just on but not running. So we go down to, say, I don't know, 12 volts. A little bit below 12. You can say it's 2 volts here at 12. Try to make that a little easier to see. Down to 10, whatever. Now let's say something wrong with our charging system and the alternator is overcharging, running at 16.5 or even 17 volts. We're up to 2.9, so we can still measure that. And then if we get a transient, let's say it just flat out goes high, this is as high as this power supply goes, you can see here it's actually over what our simulation said it would go to, 4.1, but our microcontroller is 5 volt tolerant, so that's just fine. This likely wouldn't get that high because it's not going to sit there for any length of time. On a transient, it's going to be milliseconds long. We can turn that back down. So there's our running voltage around 2.5, between 2 and 2.5. So our sanity check of this circuit is fine, so this would work. So that is our entire circuit that we're going to use for monitoring the charging system. We're just going to look at voltage, probably up near the alternator. That's it. Thanks for watching.